welcome to my channel. Today we will see the previous year papers of SSC JE Electrical. Okay, in JE Electrical there is two papers. In paper 1 there will be three sections. In first section they will ask the general awareness, that is current affairs and sports, like that. Okay, general questions. In second section there is an aptitude, and the third one it is a core subject. Okay, today we will see the core subject. Okay guys, now let me get into the video. Okay, these are the questions that is asked during 2016, okay, for electrical. Okay, today we will saw some core electrical subject which is asked on 2016. Okay, now let me get into the question. First one, which effect of the electric current is utilized in a filament lamp? Okay, the question is which effect, that's which concept. Okay, which effect is of electric current is utilized in a filament lamp? Okay, this is the question. The options are the heating effect, the magnetic effect, the collision ionization of the gases, and the chemical effect. Okay, these are the four options. Just think and predict the answer. Okay, now let us see the answer. The answer is the heating effect. Okay, the heating effect is used in electric current utilized in a filament lamp. Okay, this is the answer. Okay, now let me get into the second question. Okay, which of the following statements about electric voltage is true? Okay, in this four option, which option is related to voltage? Okay, which is true? Okay, this is the question. The options are: voltage is directed movement of electrons, voltage causes the current to flow, voltage is the irregular movement of electrons, voltage is not always needed to cause the flow of electrons. Okay, these are the four options. Just think and predict the answer. Okay, now let us see the answer. Okay, the answer is voltage causes current to flow. That is option number 2 is the correct answer. Okay, now let me go to the third question. A material which is slightly repelled by a magnetic field is known as dash. Okay, among these four options, which material is repelled by a magnetic field? Okay, this is the question. The options are diamagnetic material, paramagnetic material, ferromagnetic material, and none of this. Okay, these are the four options. Okay, just predict the answer. Okay, now let us see the answer. The answer is diamagnetic material. Okay, diamagnetic material is one which is slightly repelled by a magnetic field. Okay, this is the answer. Now let me move into the next question. Internal resistance per cell of lead cell is always dash. Okay, the internal resistance per cell of lead acid cell is always dash. Okay, this is the question. The options are less than Edison cell, more than Edison cell, equal to Edison cell, and none of this. Okay, this question is the internal resistance per cell, okay, of lead acid cell is always. Okay, they are comparing the two cells. Okay, that is lead acid cell and Edison cell. Okay, now we need to compare these two cells and we need to identify the answer by the given options. Okay, you just think. Okay, now let me see the answer. The answer is less than Edison cell. That is, the internal resistance per cell of lead acid cell is always less than Edison cell. Okay, now let me move into the next question. Mica capacitors are characterized by all of the following except. Okay, here they are asking about the characteristics of mica capacitor. Here one of the option is wrong one, so we need to identify that wrong one, that is a wrong character regarding to mica capacitor. Okay, the options are accurate value, low losses, low leakage resistance, and stable operations. Okay, these are the four options. So in these four options we need to identify the wrong answer which is related to mica capacitor. Okay, you just think. Okay, now let me see the answer. The answer is low leakage resistance. Okay, that is the correct. There is no low leakage resistance in mica capacitor. Okay, this is the answer. Okay, now let me move into the next question. In a capacitor, the electric charge is stored in dash. Okay, the options are dielectric, metal plates, dielectric as well as metal plates, neither dielectric nor metal plates. Okay, that is in capacitor how the energies are stored. Okay, this is the question. Okay, just think. You can pause the video and think and just predict the answer. Okay, now let us see the answer. That is dielectric. Using dielectric mechanism, the electric charge are stored in capacitor. Okay, this is the answer. Okay friends, now let me move to the next question. When a dielectric is placed in an electric field, the electric field strength is dash. Okay, options are increases, decreases, remain unchanged, reduces to 0. Okay, the question is when a dielectric material is placed in an electric field. Okay, just think and predict the answer. Okay, now let us see the answer. The answer is decreases. That is, when the dielectric is placed in an electric field, the field strength will decreases. Okay, this is the answer. Okay friends, now let me move to the next question. The maximum value of potential gradient in a cable occurs in. Okay, the question is the maximum value of potential gradient in a cable occurs in dash. That is, potential gradient means the ability of conductor to conduct the current. Okay, that is the potential gradient. Okay, that is occurs in dash. Okay, in conductor, insulation, outer shield, and none of this. Okay, among these four options, the maximum value of potential gradient in a cable occurs in dash. Okay, these are the four options. Just think and predict the answer. Okay, now let me see the answer. The answer is conductor. Okay, in the conductor, the potential gradient, the maximum value of potential gradient in the cable will occur in conductor. Okay, this is the answer. Okay friends, now let me move to the next question. A 6-dot mica capacitor colored coded, that is a 6-dot mica capacitor that is coded with white, red, green, brown, red and yellow, has the capacitance value of, options are 25, 124, 250 and 925. Okay, among this option we need to find the value of capacitance using this color codes. Okay, we just think and predict the answer. Okay, now let me see the answer. The answer is 925 picofarad. Okay, there is a method to identify the capacitance using these color codes. Okay, just go through it and just know how to get this answer. Okay, now let me move to the next question. A charge exists on a conductor. The best way to remove this charge is to dash. Okay, the question is the charge is existing in a conductor, so we need to remove the charge from the conductor. Okay, what are the best methods to remove the charge in the conductor? Okay, this is the question. The options are isolate the conductor from the other charges, ground the conductor, create vacuum around the conductor, and none of this. Okay, among these four options, which will help to remove the charges from the conductor? Okay, this is the question. Okay, just think. Okay, now let us see the answer. Ground the conductor. Okay, if we grounded the conductor, the charges accumulated within the conductor will be grounded, and it is removed from the conductor and it is grounded. Okay, so the best way to remove the charges from the conductor is grounding the conductor. Okay, now let me move to the next question. The current of 5 amps flow through a conductor against a potential difference of 200 volt, the power dissipated will be dash. Okay, these are the four options. That is, the current of 5 amps flow through the conductor against a potential difference of 200 volt. The power dissipated will be dash. Okay, the options are 1000 watts, 1.1 kilowatts, 2000 watts and 100 watts. Okay, just think. Okay, now let's see the answer. That is 1000 watts. Okay, this is a direct question. The formula is P is equal to VI. That is current into voltage. So 5 into 200 is 1000. Okay, this is direct question. Using the formula, that is V is equal to power is equal to VI. P is equal to VI. So by using that formula, we can directly get this answer. That is 1000 watts. Or the 1000 watts can be also called by 1 kilowatt. It is also the answer. It is 1000 watts or 1 kilowatt. Okay, this is the answer. Okay, now let me move to the next question. Energy consumed by a heater of rating 1000 watts by operating it for a period of 2 hours will be dash. Okay, this is a direct question. That is, the energy consumed by a heater of rating 1000 watts by operating it for a period of 2 hours will be dash. Okay, here the 1000 watts will be denoted by, that is 1 hour. For 1 hour it will consume 1000 watts. If for 2 hours, how much power it will be consumed by the heater? Okay, this is the question. Okay, the direct answer is 2 into 1000. Okay, 2000 watts or 2 kilowatts. Okay, this is the answer. Okay, now let me see the answer. See, the answer is 2 kilowatt. Okay, now we'll move to the next question. Copper has less resistance than aluminium and has a greater tensile strength than aluminium. To work, copper proves an excellent material as compared to aluminium. In spite of this, nowadays aluminium is extensively used in transmission and distribution of power supply because, okay, the question is, the copper having good characteristics to conduct the electricity than the aluminium. Okay, but in spite of this, we are using aluminium, not okay, but mostly aluminium is used for power transmission. Okay, they are asking the reason. These are the four options. That is, it is cheaper than copper. Copper is not available. It is light in weight, or it is easily available. Okay, these are the four options. The correct answer is, it is cheaper than copper. Okay, due to less cost than the copper, aluminums are used for power transmission. Okay, this is the answer for this. Okay, now let me move to the next question. The resistance R1 and R2 are connected in parallel. The ratio of values of resistance R1 is to R2 is 4:1. Okay, the current in R1 is to R2 will be equal to dash. Okay, the options are 4:1, 1:4, 1:1 and 4:4. Okay, this is the option. Just think. Okay, now the answer is 1:4. Okay, this is a simple one. Just think, the ratio of resistance is 4:1. The current R1 is to R2 will be, that is the reciprocal of 4:1. Okay, where the resistance is high, the current will be low, and where the resistance is less, the current will be high. So here the resistance is high, so current will be low, that is 1. Here the resistance is low, the current will be high, that is 4. That is the 1:4. Okay, just if you know the concept very well, we can solve this type of questions easily. Okay, now let me move to the next question. Kirchhoff's law states that in a closed loop of a current, closure of a circuit is dash. Okay, the options are, these are the 4 options. Okay, just think and identify the answer from this given option. Okay, the option is the algebraic sum of potential difference is 0. Okay, this is the answer. Okay guys, thanks for watching this video. In the next video we will see much more questions in SSC JE previously asked questions. Okay, thank you.